Hi guys. Hi everyone. Good evening. Good evening. Yes, today we'll be seeing matrices. We have already seen what is a matrix, how do you represent a matrix, what is an order of a matrix, and few examples of it. In this session, we will be seeing the types of matrix and its operations. Okay. So now let's quickly go into the video and let's quickly see the types of matrix. So now types of matrix, there are many types of matrix. So the first important one is our row matrix. So what is row matrix? Okay. So a row matrix, by the name itself, you can say that it should just have a row. In the matrix, what it should be? It should just have a row. So a matrix having only one row. Only one row is called as row matrix. So what is it called as? It is called as row matrix. Okay. Now, what about the example? So, if it is only one row, how will it be? There can be any number of columns. Okay, you should just have one rows. So, basically, I am giving an example. For example, A is equal to 1, 5, 3 minus 7. So, here, when you see how many rows are there are just one row. And how many columns are there? There are four columns. 1, 2, 3 and 4. So there are just one row and there are four columns. So in this way, like how do you write the order? Generally, we write the order as row into column. So here the order is 1 cross 4. So it is we have one row and four columns. So in this case, you say it is a row matrix. Okay. Now, in general, it can be, how can the order be in general? So in general, it can be 1 cross n. So the order in general can be 1 cross n. You can have as many as columns. You can have as many as columns, but you should just have one row. So that one row is very important. The n can be anything. You can have 1 cross 3, 1 cross 5, 1 cross 100. You can have any number of rows. Any number of columns, but you should just have one row. So basically, you can just remember it as a horizontal line. Okay, like this, you can remember. Basically, you can remember it as a horizontal line. Okay, now let's go to the next thing. Next important matrix is nothing but our column matrix. So same way, when you look at the term column matrix, you can identify the properties of it. So basically, you should just have one column. Like in rows, you had one rows. Same way in column, you should have one column. So column matrix. So column matrix, so basically you'll be having one column. So a matrix having one column. So if you have a matrix and that is having you just have one column, it is called column matrix. So what it is called? It is called column matrix. How do you represent a column matrix? So for example, you can write A, same A, this will be 3, 7, 0. So when you look at the matrix, you can clearly identify you just have one column. Generally, you know, right? Columns are nothing but it is the vertical arrangement generally. Rows are horizontal arrangement. So in column, you just have one column, and in rows you have 1, 2 and 3 rows. So in this case, what can you say? You can say that it is a column matrix. Since what is the order? So totally how many rows are you having? You're having 3 rows and 1 column. So in a column matrix you can have as many as number of rows, but you should just have 1 column. So basically your thing will be n cross 1. So you can have n rows but only 1 column. Are you clear? So this is the main thing which you definitely have to know about the row and column. Now every types are important. It is not necessary only this is important, everything is important. Now let's go to our zero matrix. So when you spell the word zero matrix itself, you will be able to identify. What can you identify? From the name itself, we'll know the elements inside the matrix should be 0. So in that case, what can you say? It is a zero matrix. Okay. So here one main thing about the types of matrices, in the name itself you could identify the definition. Zero matrix means the elements inside it should be 0. Inside the matrix you are having, see here you are having 370, right? In that case you cannot say that as zero matrix. So every element inside the matrix should be 0. Then you call that element as zero matrix. Okay. Now let me write it. So an M cross N matrix. So you're having M cross N matrix, right? So here what can you write? Whose each element is 0. So what can you say? Your every element is 0. Okay. Now each element is 0. So every element inside the matrix is 0. So then you call each element is 0, then is called a zero matrix. So what can you call it? You can call it a zero matrix, and zero matrix is also called as a null matrix. So zero matrix or a null matrix, you can write it in this way. So what can be the order? It is like this, we have a fixed order, right? In these two, like that you do not have any fixed order. You can have any number of order. Here M cross N, so your M and N can be any order, but the elements inside that should be 0. For example, I can take A as 0 0 0, or I can take B as 0 0 0 0 0 0. So this order is 3 cross 1 and this order is 2 cross 3. So here both of them are zero matrix, but this is a column matrix also. So your A is column and a zero matrix, and your B is zero matrix. Okay, you can say A as a column matrix or a zero matrix. Okay, it is both column and zero matrix. Okay, so these are the examples. The order is not fixed here. You can have any number of, like any order, but the elements inside that should definitely be 0 0 0 0. Like every element inside it should definitely be 0. Okay, now let's talk about the next matrix, which is square matrix. So when you talk about square matrix, from the word itself, what can you understand? How will a square be? So yes, tell me, how will a square be? So how will a square be? So generally when you talk about a square, so when you see all your sides are equal in a square, you know that, right? But can you relate it to a matrix? So in a matrix we have rows and column. In a normal 2D diagram we have breadth and length. So here in a square everything will be equal, all sides are equal, which means breadth is equal to length. Same way in a matrix, when your rows and columns are equal, that matrix is called a square matrix. Same way, just remember the name, you will be able to get the idea. So in a square matrix, your number of rows and your number of columns should be equal. Only then you call that matrix as a square matrix. Okay. So a matrix in which number of rows is equal to number of columns. So your number of rows is equal to number of columns. So then, so both, you say both equal to n, say n, okay. Number of rows, you keep it as n, number of columns, you keep it as n. So this is called a square matrix. So how do you name it? It is called a square matrix of order n. So how can you name it? You can call this matrix as a square matrix of a order n, or a n rowed square matrix. So how do you name it? It is n rowed square matrix. You have two representation for it. So let me give you an examples for it. So when you see first example, you have A is equal to 1, 2, 3, 4. So what is the number of rows? So when you check the number of rows, how many rows are there? You have 1, 2, 1 and 2. So you are you're having 2 cross 2. So your number of rows here is equal to number of column, that is equal to 2. So this is nothing but a square matrix. What is the order? Of order 2. This is a square matrix of order 2. So can I tell some other example? Now, if I take an example B, which is 1, 1, 1, 1, 1, 1. So is this a square matrix? When you see, you have 2 rows and 3 columns. So here, the number of rows is not equal to the number of columns. So it is not a square matrix. So this is not a square matrix since your number of rows is 2 and number of columns is 3. So they are not a square matrix. Okay. Now what can you do? Now let's see for the next type. So under square matrix, you have different matrices. So under square matrix, you have one of the main matrix, which is called, like when you write a square matrix, you will represent a square matrix like this, right? So generally you are having a square matrix. So you can write it as A11, A12 up to A1n. So it will be up to AN1 up to ANN. So here it will be A22, here it will be A33, so it will go. So this is the diagonal elements. So your diagonal elements are basically when basically this is your A, right? This is your square matrix of n cross n. So how can I write? Basically I can write it as the whole bigger matrix, or I can represent it with a smaller thing. How can I represent? It will be Aij. So the element inside it can be represented. So what are the main diagonal elements? So diagonal elements for which I is equal to j, so your I is equal to j, those are called diagonal elements. So are called diagonal elements. So here when you see A11, A22, A33, those are the diagonal elements. Okay. So here when you talk about it, so this element is nothing but A11. This element is nothing but A22 because it is second row and second column. So your diagonal elements are 1 and 4 for it. Okay. So these are called diagonal elements. So are you clear with it? Are you clear about it? So now let's further expand it and write it. Basically it will be 1 1 A1 A22 A33 and A44 up to ANN. So these are the diagonal elements. So here the diagonal elements are 1 and 4. But here, yeah, basically if I give some other example, let me give you another example. Your matrix 2, 3, minus 1, 4, 7, 9, 0, 1, 3. Now can you tell me how many rows and how many columns are there? There are 3 rows and 3 columns. So what are the diagonal elements? Basically my diagonal elements are A11. So this is my A11. What is A22? A22. What is A33? A33. So the elements which are in the diagonal, exactly the diagonal, not the opposite diagonal. This diagonal you cannot take. Okay, you're just taking the you're just taking the main diagonal where I is equal to j. Okay, so here the diagonal elements are 2, 7 and 3. Now these are the main, this is one of the main concept, that is square matrix. Now let's quickly go to our other types, which this fifth type, that is our diagonal matrix. So when you hear the word diagonal matrix, what comes to your mind? Generally diagonal means, you know what is it, okay, you know the elements. So there should be elements only in the diagonal. Other elements apart from this should be 0. That kind of matrix is called diagonal matrix. So, and one more important thing, a diagonal matrix, for it to be a diagonal matrix, definitely it should be a square matrix. So a square matrix A is equal to Aij. Like this only I told you, in the previous class. We represent a matrix in this form. Is called, how it is called? It is called a diagonal matrix. How do you call it? It is called a diagonal matrix if its non-diagonal elements are 0. If and only if all its non-diagonal elements are 0. So all of its non-diagonal elements are 0. So now for you there will be a confusion. What about the diagonal elements? Should it be 0 or shouldn't it be 0? It is not necessary. It can be 0. The diagonal elements can be. It may or may not be 0. So the diagonal elements, you should not necessarily tell that it shouldn't be 0. It may or may not be 0. So it may or may not be 0. So what can you say? You can say that the diagonal elements may or may not be 0. For example, if I take, so this A is equal to 3, 0, 0, minus 1. So it is 2 cross 2. So the first condition is which is there, which is a square matrix. Now look at the diagonal. So this is my diagonal elements, which is 3 and minus 1. What are the non-diagonal elements? The apart from this highlighted thing, everything is non-diagonal element. All the non-diagonal elements are what? They are 0. Since they are 0, you can call this as a diagonal element. Okay. One more example is B is equal to 5, 0, 0, 0, minus 2, 0, 0, 0, 0. So this is again a 3 cross 3 matrix. So this is a square matrix. That condition is there. Apart from this, look at the diagonal. This is the diagonal. So what are the non-diagonal elements? The elements which are above and below diagonals are non-diagonal element. So those are 0. Look at the diagonal elements now. It is 5, minus 2, 0. So I already told you the diagonal elements may or may not be 0. But other elements should definitely be 0. So this is a diagonal matrix example. Yeah. Now let's go to the sixth type. Our sixth type will be scalar matrix. So what is a scalar matrix? So for it to be a scalar matrix, definitely it should be a diagonal matrix. So let me write the hierarchy. For it to be, it should be a square, then only you can say it is a diagonal. A square matrix only you can say it as a diagonal. Same way, for a scalar, it should be a diagonal matrix. Only for diagonal matrix, you can just start with the condition. So a diagonal matrix which all diagonal, so all the diagonal elements in the diagonal matrix should be equal. Then you say it as a scalar matrix. So all the diagonal elements are equal. So all diagonal elements are equal. Then it is said is called what? Is called a scalar matrix. So how can you call it? Then you call it as a scalar matrix. For if I say A is equal to Aij, where it is n cross n. Okay. So now Aij, the element will be 0. If I and j are not equal, which means, see, diagonal matrix only if ij is equal, you will be having an element. If ij is not equal, you will be having 0. That is the representation of a diagonal matrix. But here it will be k. K is constant. All those elements whose I and j are equal, the elements will be same. So for example, I'll tell you. If I tell you this is A, which is -1, 0, 0, -1. So here it is 2 cross 2. So definitely it's a square matrix. Is it a diagonal matrix? Yes. The diagonal elements are filled. Apart from the diagonal elements, other elements are not filled. In this case, what can you say? It is a diagonal matrix. But look at the diagonal elements. I'm having -1 here and I'm having -1 here. So all the diagonal elements are same. So then you can call this matrix as a scalar matrix. Now what about the other one? So B, if I take, it will be 5 0 0 0 5 0 0 0 5. So here it is 3 cross 3. Now again, when you see itself, the diagonal elements are only filled. So it is a diagonal matrix. Since the diagonal elements are same, so what can you say? It is a scalar matrix. Okay, so these are the scalar matrix generally. Now what about the other one? How do you what about the next further one, which is our one more important matrix? Totally you have 8 types. So this is my 7th matrix. Let me see. 7th matrix is basically the identity matrix. So it is identity matrix. So I'm just giving in the order. For it to be an identity matrix, it should definitely be scalar matrix. What are scalar matrix? It is a diagonal matrix whose diagonal elements are same. So I told you the diagonal elements are same. If the diagonal elements, the same element is 1, that is called identity matrix. If the diagonal elements are 1, that is called, all the diagonal elements are 1. Apart from that, other elements are 0. That is called identity matrix. So it is a scalar matrix in which each diagonal is unity. So each diagonal is unity means 1. Okay, each diagonal is unity means 1. So is called a identity matrix. How, what is it called? It is called a identity matrix, or you can call it as a unit matrix, or what can you call it as a unit matrix. So you can call it as a unit matrix. So here, so as I already told you, here you have K. So K can be 5, 6, 7, 8, anything. No, K is a constant. All the diagonal matrix should be same alone is given in scalar. But here that K will be your, what is that K? That K will be your 1. So that K will be a 1. So A is represented as Aij, where it is n cross n. Okay. So now let me give you an example. So example, if I take A is equal to 1, this is a matrix. What is, this is 1 cross 1 matrix. So it is a diagonal matrix. It is, how do you represent it? It is represented just I1. It is identity element 1. Same way, if you take about B, it is nothing but 1, 0, 0, 1. Look at the diagonal elements. The diagonal elements are just 1. So what can you say? It is identity. So how do you represent it? You can represent it as I2. What about order 3? So this is 2 cross 2. What about I3 is 1, 0, 0, 0, 1, 0, 0, 0, 1. The diagonal elements for the diagonal elements all are same, and that is equal to 1. So you call that matrix as a I3 identity matrix of order 3. Okay, so generally diagonal matrix are denoted by IN. Here n is nothing but order of matrix. So I already told you diagonal elements, identity element is a identity element is a square matrix. So the order, number of rows and number of columns will be same. So you are having just 1n. So like this only we'll be able to represent our identity matrix. Now let's go to the upper, triangular matrix. So 8th one is triangular matrix. So here you are having upper triangular matrix, lower triangular matrix. Okay. So first let me go with the upper triangular matrix. So upper triangular matrix. So if it is an upper triangular matrix, generally it is like when you take a square matrix, it should definitely be a when you take an upper triangular matrix, it should definitely be a square matrix. Okay, so a square matrix A is equal to Aij n cross n. Then that is called upper triangular matrix is called upper triangular. I'm just writing it as triangular matrix. So when, if and only if Aij is equal to 0 for all I greater than j. So for all I greater than j, your thing will be equal to 0. So if and only if, what can you say? The all elements below the principal diagonal are 0. So all elements. So you can represent it in mathematically this way. Otherwise, colloquially you can say all the elements in a square matrix, you have a diagonal element. So all, not even that diagonal element. So all the diagonal elements, all the elements below the diagonal elements are 0. So all elements below principal. So all elements below principal diagonal are 0. So basically, if I take an example, this will be A is equal to 1, 2, 3, 0, 1, 2, 0, 0, 0. Okay. So what is my diagonal matrix? So this is my diagonal matrix. So all the elements below it are 0. When you take a triangle, this is the triangle. So basically when you're having, but here, upper triangular means you just remember that you're having a diagonal, all the elements above the diagonals are filled. Just remember that below should be 0. Okay, the diagonal, leave it, that we're not concentrating. Now let's go to a lower triangular matrix. Lower triangular matrix. So lower triangle, I'm just writing the symbol as triangle. So lower triangular matrix, how do you represent it? It is again a square matrix. How do you represent it? So square matrix A is equal to Aij. So it is called, so this is called lower triangular matrix. So this is called lower triangular matrix if and only if Aij is equal to 0 for I less than j. Okay, otherwise you can say all the elements which is above the principal diagonal are 0. If and only if all elements above principal diagonal are 0. So all elements above principal diagonal are 0. So how can you say, so if you have an example, so here 1 2, so above it 1 0 2 0 1 3 1 1. So what is a main diagonal? This is your main diagonal. So lower triangular matrix means the lower part alone, below the main diagonal you are having elements, no, these elements only that will be filled, above part shouldn't be filled. So all the elements above the principal diagonal are 0. In this case you can say this is a upper triangular matrix. Okay, now in general you are having a name called just a triangular matrix. So triangular matrix. So you are, in general you are having one more thing, triangular matrix, a matrix, be it a upper matrix or lower matrix. So generally a matrix, upper or lower triangular matrix, lower triangular is called triangular matrix. So it can be upper triangular matrix or lower triangular matrix. This is called a triangular matrix. So what is this called? This is called a triangular matrix. Okay, so here you say it is strictly triangular when even your diagonal elements are 0. So a triangular matrix, that is A is equal to Aij n cross n, is called strictly triangular. So what is called? It is strictly triangular matrix. So when do you say it is strictly triangular matrix? If your Aij is equal to 0. Okay, basically what your both your diagonal matrix, your I can say it as I, both are 0 for I is equal to 1 2 3 up to n. So if and only if both are 0. So if and only if both are 0. So for example, if I tell you a matrix, this is 0 0 0 1 0 2 0 2 5 0. So what is the main diagonal? The main diagonals are 0 0 0 and it is a matrix, it is a lower triangular matrix. So here, right, it is a lower triangular matrix since lower thing is filled. So even your diagonal elements are 0. So you can say it is strictly lower triangular matrix. Okay. So yes, that's all for today's class. It is mainly about matrices and types. And next class we'll be learning its operations. So yes, that's all. Thank you and have a nice day. Next class we'll be with a good content, that is solving sums of these matrices and few more operations. So yes, thank you.